Hi, welcome to my channel, The Magic Math, where we master math one video at a time. My lesson today is on solving absolute value inequalities. That's what you will do today. You will solve absolute value inequalities. The question I'd like you thinking about today as I proceed through the lesson is, how is solving an absolute value inequality similar to solving an absolute value equation? And how is it different? So in a previous video, I have discussed how to solve absolute value equations. So my students are now on to their next unit of study with inequalities, and we end by solving absolute value inequalities. So today, we're going to talk about what is an absolute value inequality. An absolute value inequality is an inequality that contains an absolute value expression. Here's an example. We have the absolute value of x greater than 4. Remembering that an absolute value equation could be something like this. The absolute value of x is equal to 4. So what's different today is you're going to have greater than, less than, greater than or equal to, or less than or equal to, instead of an equal sign. But remembering back to our previous learning that this states that the distance between x and 0 is 4. And the solutions of this are -4 and 4. So if we can recall our previous learning, and now we're going to apply it to inequalities. Let's talk about the absolute value inequalities that have an OR solution set. The absolute value inequality, the absolute value of x is greater than 4, states that the distance between x and 0 is greater than 4. The solutions of this inequality, which we will get to soon, are that x is less than -4 or x is greater than 4. So trust me on this part, and I will show you how to solve this in a future slide. Let's first graph our solution set. We're going to have an open circle on -4 and shade it to the left because it's less than, and it cannot be equal to, so don't shade it in. An open circle on 4 because it cannot be equal to, and then shaded to the right because it's greater than. So this represents our solution set, and you can see that it is an OR because the union is anything that can be in one or the other. Let's note that the solution set of an absolute value inequality with a greater than or equal to will have an OR solution set of inequalities. However, there is a rule breaker unless there is a special solution. So just like with our previous learning of compound inequalities, when we had to look for no solution, all real numbers, or one inequality, or even one value, we need to watch out for that for absolute value inequalities as well. Now let's look at an absolute value inequality that is an AND solution set. So the absolute value inequality, the absolute value of x is less than 4, states that the distance between x and 0 is less than 4. The solutions of this inequality are that x is greater than -4 and x is less than 4. So again, I'll show you how to solve this in a minute, but let's take my word for it that this is our solution set. Let's graph that so that we can visually see that this is represented by an AND. We're going to put an open circle because it cannot be equal to on -4, and shade it to the right because it's greater than. Then we're going to have an open circle on 4 because it cannot be equal to, and then shade it to the left. So you can see that we have this intersection of solutions and represents our AND. Now, special note, the solution set of an absolute value inequality with a less than or less than or equal to will have an AND solution set of equalities, unless there is a special solution. So very important that when you are done solving, you graph your solution set to verify the AND, the or special solution instance. Now let's talk about how we solve an absolute value inequality. There are 4 steps. So to solve an absolute value inequality, step 1, if necessary, isolate the absolute value expression using inverse operations and properties of inequalities. Step 2, rewrite the absolute value inequality as a compound inequality. So if you remember back to solving an absolute value equation, we wrote two equations when we dropped the absolute value symbol. We're going to write two inequalities here, which we call a compound inequality. One inequality without the absolute value, so we'll drop the absolute value symbol and keep everything else as it is. The second inequality, we're going to drop the absolute value symbol, reverse the inequality sign, and multiply the other side of the inequality by -1. So this part is the same as an equation, but reversing the inequality sign is what's different. And remember, when you multiply something by a negative value, you have to reverse the symbol. Step 3, we're going to solve the compound inequality using our inverse operations and properties of inequality. And step 4 is probably the most important part. We're going to graph our solution set to check for a special solution and show our representation of our solution set. Now let's solve. We have the absolute value of 2x minus 1 is greater than or equal to 7. Step 1 is, if necessary, isolate our absolute value expression. It's not necessary, it's already isolated. Step 2, now it's time to rewrite it to our compound inequality. So here we go. The first inequality is going to just drop the absolute value symbol and everything else stays the same. The second inequality, we're going to drop our absolute value symbols. We're going to reverse the inequality symbol and multiply the right by -1. Now we need to solve. That's step 3, solve our compound inequality. I'm going to do the inverse of subtract 1, which is to add 1 to each side, leaving me 2x is greater than or equal to 8. To get x alone, I'm going to do the inverse of multiply by 2 and divide each side of the inequality by 2. That leaves me x is greater than or equal to 4. 8 divided by 2 is 4. Let's solve the second. The inverse of subtract by 1 is to add 1 to each side, giving me 2x is less than or equal to -6. Divide each side by 2, and -6 divided by 2 is -3, so x is less than or equal to -3. Now we're ready for step 4, which is to graph. Here's my number line with the values I need. I need a closed circle on 4, closed circle shaded to the right because it can be greater than, closed circle because it can be equal to, and shaded to the left because it's less than. You can see we have a union, so we need an or. X is less than or equal to -3, or x is greater than or equal to 4 is our solution. Your turn. I would like you to pause and solve. If you need to go back a little bit in the video to write down the 4 steps, I highly recommend you do that. Come back and hit play when you're ready to see the solution. Welcome back. The solution is, step 1 would be to isolate the absolute value expression, which is already isolated. Step 2, we're going to write our two inequalities forming our compound inequality. So the first one, we're going to drop the absolute value symbols and everything else stays the same. The second, drop the absolute value inequality, absolute value signs, and we reverse the inequality symbol and multiply the right by -1. Now, step 3 is to solve our compound inequality. The inverse of add 3.5 is to subtract 3.5 from each side, leaving me x is less than or equal to 4.5. Solve the second. I'm going to do the same thing. The inverse of add 3.5 is to subtract 3.5 from each side, giving me x is greater than or equal to -11.5. Now we're going to graph our solution set. So I need -11.5, my 0, and my 4.5. I need a closed circle on 4.5 because it can be equal to, shaded to the left because it's less than. I need a closed circle on -11.5 because it can be equal to and shaded to the right. So we have our solution, which is the intersection of our two inequalities. So we can write it x is greater than or equal to -11.5 and x is less than or equal to 4.5. Or you could write it -11.5 less than or equal to x less than or equal to 4.5. Your turn. Try this one. Please pause and come back and hit play when you're done. Welcome back. I hope you didn't get caught on this one. So the first thing when we're solving anything absolute value, we want to stop and think. The absolute value of anything, it doesn't even matter what is inside of here, can never be less than 0. So we have no solution. If you're asked to graph, when you have no solution, you just put an empty number line. It's kind of an empty set, we call it in math, but you just wouldn't graph anything on it, just show your number line. Your turn. Go ahead and solve. Come back and hit play when you're ready. Welcome back. So here we go. Some students get tricked by this. This is not less than, it's greater than. So this is always going to be true because it will always be greater than -3. So it's all real numbers. Any value that you put in here is going to result something that is greater than -3 or equal to. It will never be equal to, right? But it will always be greater than. So our solution set would be, graphed, would be the entire number line. All real numbers. Now let's solve an absolute value inequality that we need to isolate our absolute value expression. So step 1, we identify that our absolute value expression is not alone. So we're going to do the inverse of add 2 first and subtract 2 from each side, giving us 3 times the absolute value of x plus 4 is greater than 21. Our absolute value expression is still not isolated, so the inverse of multiply by 3 would be to divide each side by 3. Now we have our absolute value expression isolated. So step 2 is to write our compound inequality. So the first one, we're going to drop the absolute value symbols and leave everything else the way it is. On the second, we're going to drop the absolute value symbol, reverse the inequality symbol, and multiply the right by -1. Now we're ready to do step 3 and solve our compound inequality. The inverse of add 4 is to subtract 4 from each side, giving me x is greater than 3. Solve our second. The inverse of add 4 is to subtract 4 from each side, giving me x is less than -11. Now we're going to do step 4 and graph our solution set. So I'm going to put an open circle on 3 and shade it to the right, an open circle on -11 and shade it to the left. So my solution set can be written as x less than -11 or x greater than 3. Your turn. Please solve, graph, and come back and check your work. Welcome back. So our first step is to isolate our absolute value expression. So I'm going to do the inverse of subtract 12 and add 12 to each side. Now I have 1/2 times the absolute value of x minus 1 is less than 1. I still haven't isolated my absolute value expression, so I'm going to clear this fraction of 1/2 by multiplying each side by 2, giving me the absolute value of x minus 1 is less than 2. Now I'm ready to write my compound inequality. So my first inequality, we're going to drop the absolute value symbol and everything else stays the same. The second, I'm going to drop my absolute value symbol, reverse the inequality symbol, and multiply by -1. Now I'm going to solve my compound inequalities. The inverse of subtract 1 is to add 1 to each side. That gives us x less than 3. Now I'm going to solve my second. The inverse of subtract 1 is to add 1 to each side. That gives us x greater than -1. -2 plus 1 is -1. Now we need to graph. Here's our number line. I need an open circle on 3 and shade it to the left for less than. I need an open circle on -1 and shade it to the right for greater than. So this is our intersection of our two inequalities. So it is an and. X is greater than -1 and x is less than 3. Or you could answer -1 less than x less than 3. What is absolute deviation? So absolute deviation is a real-world application now that you understand absolute value inequalities. The absolute deviation shows the amount something varies above or below a certain value. To find the absolute deviation, you can find the absolute value of the difference of the value x and the given value and compare using an equation or inequality to the absolute deviation. So we learned about this in our absolute value equation unit. We have the absolute value of x subtract that given value, that plus or minus. So it's going to, it could be plus, but typically in real world, it's always going to be subtract because we're shifting it to the right of 0. And then we're going to have this empty box. And that's equal to our absolute deviation, which is that amount plus or minus. We can have an equal sign, a less than, a greater than, a less than or equal to, or a greater than or equal to. So in our previous unit, we did equal. Today, we're going to do one of our 4 inequality symbols. Here's an example. It takes you 17 minutes to get to school each morning after you get on the school bus. Your arrival time can vary up to plus or minus 4 minutes depending on the weather, the traffic, and student pickups. So this should seem pretty applicable to you. Once you get on the school bus, you pretty much get to school at the same time, but you never know. Somebody could be running late to catch the bus. There could be a car accident or traffic, or there could be bad weather slowing the bus down. We're going to write an inequality that will model the situation. So I always like to start with a graph, with a number line. So we know that first we're talking about 17 minutes. So typically it takes 17 minutes for the school bus to get you to school. But sometimes it could take longer, and it could vary by up to 4 minutes. So it could be a closed circle, and it could be 4 minutes more is 21 minutes. Or we could be faster and hit no traffic, no weather, and maybe somebody isn't even at their bus stop and I don't need to stop, so fewer stops. So it could be subtracting 4 minutes from my average time. So that would be 13 minutes. So I can arrive at school anywhere from 13 minutes to 21 minutes. Now we can write this as an absolute value inequality. So 17 is the distance I am from 0, so I need to subtract that to get it back to 0, and it's going to be less than or equal to 4. So I can be plus 4 or minus 4. So there we have it. If you solved this this absolute value inequality, writing a compound inequality, you would get the answers that x had to be greater than or equal to 13 and less than or equal to 21. Your turn. I would like you to figure out how to write an inequality to model the situation. You have a bag of your favorite candy that contains 56 pieces of candy. The number of pieces of candy in each individual bag can vary by plus or minus 5 pieces. Please pause, write your absolute value inequality, and come back to check your work. Welcome back. So first I'm going to start with a number line. So on average, we have 56 pieces of candy in our bag, but that can vary. It can have up to 5 more, which would be 61. Or it could have 5 less, which would be 51. So when we go to write this, we've shifted from 0 by 56, so we've got to take that away, and it's going to be less than or equal to 5. So there you have it. That's how you solve absolute value inequalities. Don't forget to check before you write those 2 compound inequalities. Is it even possible? And always graph your solutions to check for a special solution. Thanks for joining me at the Magic of Math, where we're mastering math one video at a time. Please subscribe and have a great day.